All right, so here's some examples that are similar to the ones on your review for number 1 and 2 on the radicals. So first thing I'm going to do is I'm going to factor tree. So I'm going to break down these numbers. So 16 we can break apart into 4 and 4. And then 4 we can break apart into 2 and 2 and 2 and 2. I also have x to the 12th, so I have 12 x's. And 8 y's. Now, because this is the fourth root, we're going to circle groups of 4. So I've got a group of 4 2's that I can circle. I've got 3 groups of 4 x's and 2 groups of 4 y's. So this will simplify into a 2x cubed y squared. Now for number 2, we're going to do the same thing. I'm going to factor tree 162. So off the top of my head, 162 is even, so if I divide that by 2, I get 81. Now I can't break apart the 2, but I can break apart the 81 into a 9 and a 9. And then I can break apart the 9s into 3 and 3 and 3 and 3. I also have 7 x's and 11 y's. So I'm going to write out 7 x's and 11 y's. And then again, because this is the cube root, now I'm going to circle 3 of a kind. So I've got 3 of a kind of 3's. I've got 2 groups of x's and 3 groups of y. So whatever we circle is going to come outside of our square root. So I'm going to pull a 3 on the outside, an x squared, and a y cubed. Now, I have items that I didn't circle. So I didn't circle a 2, a 3, an x, or y squared. Those are going to stay inside this cube root. So inside is a 2 times 3, an x, and a y squared. Well, 2 times 3 is 6. So this is a 6xy squared on the inside. All right, so here's example types that are similar to number 3 and 4 on the radicals test review. So number 3, I'm dividing this function inside the square root. So the first thing I'm going to do is divide or reduce inside the square root. Okay, so inside, 63 divided by 7 is 9. X to the 9th divided by x to the 5th, we subtract their exponents. So 9 minus 5 equals 4. So this would be x to the 4th. And then when I look at my y's, y to the 4th divided by y to the 10 is 4 minus 10, which is negative 6. And all that means is y to the 6th is going to be on the bottom. And then I'm going to take the square root of each piece. So the square root of 9 is 3. The square root of x to the 4th is x squared. And the square root of y to the 6th is y to the 3rd. So similar on 4, we're multiplying. So like on 3, where we divided first and then we simplified the radical, on 4, we're going to multiply first and then simplify the radical. So first, I multiply the outsides together, so I'll get negative 10. This will stay the cube root. And then I multiply the insides together. So 5 times 25, or 75, is 375. Oh, when I do the x's, x to the 4th times x. Remember, when we multiply, we add exponents. So this would be x to the 5th. And then y to the 6th times y squared would be y to the 8th. And now this problem should look like number 1 and 2, so we are going to factor tree that inside. So 375, we just found out, is 5 times 75. 75 is 25 times 3. And 25 is 5 times 5. I also have 5 x's and 8 y's. Now, because this is the cube root, we're going to circle groups of 3. So 3 of a kind. So I get a group of 5s, a group of x's, and 2 groups of y. So whatever I circle comes outside my radical. So 5 x y squared. And whatever I don't circle stays inside my radical. So I didn't circle a 3, 2 x's, and 2 y's. So inside goes 3, 2 x's, and 2 y's. Now, the only other thing we can't forget about is this negative 10 that we have on the outside. So we have negative 10 times this function. So we get negative 50xy squared, cube root of 3x squared y squared. All right, so here is example problems that are similar to 5 and 6 on the radicals review. So 5, we're adding radicals. We cannot add each radical unless they are the same number underneath the radical symbol. So what I'm going to do is simplify each of these first. So 75, we can simplify into 25 and 3. Sorry, I like this part color better. And then 25 is 5 and 5. Now, because there's no number written out in front, we assume it's a 2, square root. So we circle 2 of a kind. So I've got a group of 5s. So this is 5 square roots of 3, because 3 is what's left over. And then I'll do the next one. 27 is 9 times 3, and 9 is 3 times 3. So again, the square root means I circle groups of 2. So I have a 3 square roots of 3. Now don't forget this 4 that we have in front. So we have 4 times 3, radical 3. And I can't simplify this radical 3, so it's going to stay radical 3. So I have 5 square roots of 3 plus 12 square roots of 3 minus 1 square roots of 3. 5 plus 12 is 17. Minus 1 is 16. So I have 16 square roots of 3. Now, on example 6, we cannot have a radical in the denominator. So to cancel out this square root in the denominator, I'm going to multiply by the square root of 3. Multiply it by itself. Well, if I do something to the denominator, I have to do the same thing to the numerator. So this becomes 7 square roots of 3 over the square root of 9. And the square root of 9 is 3. So this is 7 square roots of 3 over 3. All right, so these are examples of problems 7 and 8 that are similar to the radicals test review. So if I look at number 7, first thing I notice is that I cannot have a radical in the denominator. So to cancel out this radical in the denominator, I'm going to multiply by what we call the conjugate. And the conjugate is the same term, just the opposite sign. So this would be 8 minus the square root of 2. Now if I multiply by something on the denominator, I have to multiply the same thing on the numerator. So 8 minus the square root of 2. And then we'll start distributing. So on the top, I'll distribute my 6 to each. So 6 times 8 is 48, minus 6 square roots of 2. And then on the denominator, I have to distribute the 8 to each first. So 8 times 8 is 64, minus 8 times the square root of 2 is 8 square roots of 2. And then distribute the positive square root of 2 to each. So this becomes plus 8 square roots of 2 minus the square root of 4. And then I'll simplify. I can't do anything on the numerator, so the numerator stays. Now on the denominator, I notice that the negative 8 square root of 2 and the positive 8 square root of 2 cancel out. And then square root of 4, really, this is just a minus 2. So when I combine like terms, 64 minus 2 is 62. Now, while I'm all pretty much done, I notice that all of these numbers here are divisible by 2. So I can reduce all of these by 2, which will give me 24 minus 3 square roots of 2 over 31. And that'll be our answer. Now 8, I notice I have a fractional exponent, so I'm thinking to bow tie this problem. So the bottom goes out. This is the 5th root of 32 to the negative 3rd power. And I like to do the root part first. So the 5th root of 32. Well, the 5th root of 32 is 2. So this becomes 2 to the negative 3rd power. The negative exponent means it goes on the denominator. So this is 1 over 2 cubed. And this is 2 to the 3rd power, not 2 times 3. So this is 1 over 8. All right, 10. So we've got examples 9 and 10 that are similar to your radicals test review. So here, whenever I am multiplying terms, I add their exponents. So I'm adding the exponents of 2/5 plus 3/4 for the x's. So x to the 2/5 plus 3/4. And similarly with the y's. So I've got y to the 3/7 plus 1/3. Now, to add fractions, I need common denominators here, so I can't add 2/5 plus 3/4 unless the denominators are the same. I've got a 5 and a 4, so I'm going to try and make them both 20. So that means I need to multiply the first fraction by 4 over 4, and the second fraction by 5 over 5. So I'll have 8 over 20 plus 15 over 20, which is 23 over 20. Now for my next one, 3/7 plus 1/3, a common denominator, so I multiply each side by 3. And on 1/3, I'm going to multiply by 7 over 7, so the denominators will be the same. So I'll have 9 over 21 plus 7 over 21, which will give me 16 over 21. And that'll be my answer. Now on 10, I've got a term inside our parentheses with an exponent. I don't have any adding or subtracting in here, so I am allowed to distribute this exponent and multiply the exponents here. So I've got x to the negative 5/6, and when you raise a power to a power, you multiply. This is times 24. Y to the 3/8 times 24. So when we multiply fractions, this is like negative 5 over 6 times 24 over 1. And we can multiply straight across, or we could reduce first. 6 goes into 24 4 times. So this would be negative 20 over 1. So I'd have x to the negative 20th. I can do the same thing with the y exponent, 3 over 8 times 24 over 1. I can reduce the 8 and the 24. These both reduce by 8. So this would be a 1 and a 3, which would give me 9 over 1. So I'd get y to the 9th. Now we want to add with positive exponents, so the negative exponent on the x will make the x term go to the denominator. So I've got y to the 9th over x to the 20th. All right, 11. 125, x to the negative 9th, y to the 6th. So here's a problem that's similar to our radicals test review, that are similar to 11 and 12. So same thing on 10 for 11. We've got an exponent. So this exponent of negative 2/3, we can distribute to each term. Now, even though the 125 does not have an exponent visible, it's got an exponent of 1. So this is going to be 125 to the negative 2/3 power, x to the negative 9 times negative 2/3, y to the 6 times negative 2/3. And then we're going to simplify. So let's just go in order. 125 to the negative 2/3, we're going to bow tie. So the bottom goes out, so this becomes the cube root of 125 to the negative 2nd power. Cube root of 125 is 5 to the negative 2nd power. Negative power means it goes on the bottom, so 1 over 5 squared. So I get 1 over 25. Now when I do the exponents, I am multiplying here for the x. So I've got negative 9 times negative 2 over 3. I can reduce the 9 and the 3 by 3. So really this is negative 3 times negative 2, which equals 6. So this is x to the 6th power. Do the same thing with the y's. So 6 times negative 2/3. I could reduce the 3 and the 6 by 3. So 2 times negative 2, this is negative 4. So I get y to the negative 4th power. Negative exponents means it goes on the denominator. So this is 1 over y to the 4th. Now I'll put all 3 of these together. So on the numerator, I'll have x to the 6th. On the denominator, I'll have 25 y to the 4th. All right, and then 12. When we're solving equations, we've got an equal sign in them. We're trying to get x equals some number. So the first thing I'm going to do is subtract 4 from each side. So the square root of 3x minus 5 equals 4. Now to get rid of the square root, we're going to square both sides. So I've got 3x minus 5 equals 16. To get rid of the 5, I add 5 to both sides. So 3x equals 21, which means x equals 7. All right, so we've got 2 equations that we're going to be solving, and these correlate to 13 and 14 on the radicals review. So first thing on 13, I want to get this 2 minus 4 to the 2/3 power all by itself. So that means I need to get rid of the plus 5 and the times 3. So the first thing I'm going to do is subtract 5 from each side. So 3 times 2x minus 4 to the 2/3 power equals 12. And get rid of the times 3 in front, so I'm going to divide each side by 3. So 2x minus 4 to the 2/3 power equals 4. Now to get rid of this raised to the 2/3 power, we're going to raise each side to the reciprocal power, to the 3/2. So on the left side, the 2/3 and 3/2 equals 1. So this just ends up being 2x minus 4. And on the right side, I'm going to bow tie this. So this becomes the square root of 4 cubed. Well, the square root of 4, we took the square root of both sides. So we're going to have a positive 2 and a negative 2. So we have 2 to the 3rd and negative 2 to the 3rd. So we get 8 and negative 8. So we're going to end up with 2 parts here. We have 2x plus 4 equals 8, and 2x plus 4 equals negative 8. So for the first one, on the left-hand side, I add 4 to each side first. So 2x will equal 12. And then I get x equals 6. For the second one, I add 4 to both sides. So 2x equals negative 4. Divide by 2, so x equals negative 2. You always want to check your answers by plugging them into the original, just to keep the video short. I'm not going to do that, but they both work, I believe. All right, 14. So same kind of idea. I want to get the square root part by itself, so I need to get rid of the plus 5. So I'm going to subtract 5 from each side. Now to get rid of the square root, we're going to square both sides. So on the left side, we have 45 minus 9x. But on the right side, x minus 5 squared means we have to do x minus 5 times x minus 5. So we distribute the x to each to get x squared minus 5x. And then distribute the negative 5 to each. So we get negative 5x plus 25. So this will go to an x squared minus 10x plus 25. Now we want to make it equal 0, so I'm going to subtract 45 from each side and add 9x. So on the left side, I'll have 0. On the right, I'll have x squared minus x minus 20. And then I'm going to factor this. So I'm looking for factors of negative 20 that have a sum of negative 1. So two numbers that multiply to negative 20 and add to negative 1 are negative 5 and positive 4. So this factors into an x minus 5 and an x plus 4. Because it equals 0, we set each one equal to 0. So x minus 5 equals 0 and x plus 4 equals 0. So x equals 5 and x equals negative 4. Now again, we need to check our answers by plugging them into our original problem. So since I didn't do it on 13, let's go ahead and do it on 14. So let's do it in purple. So I'll check the x equals 5. This is the square root of 45 minus 9 times 5 minus 5, and we're seeing if this equals 5. So all I did was plug in a 5 in for the x's. Oop, that's a plus 5 here. So this becomes the square root of 45 minus 45 plus 5. So this is 0 plus 5, the square root of 0 plus 5, which is 0 plus 5, which equals 5. So this one works. Let's try negative 4. So the square root of 45 minus 9 times negative 4 plus 5 equals negative 4. So this will be 45 plus 36 plus 5. So it'll become the square root of 81. Oh, it's a wonky 8. Plus 5. So this is 9 plus 5, which equals 14, which does not work. So we have one answer of x equals 5. All right, so we are going to be graphing this equation. So remember, anytime anything is on the inside, this moves it left and right, and it's opposite. So subtracting 3 is moving our graph to the right 3. Outside is up and down, and it's normal. So this plus 5 is moving our graph up 5. So instead of starting at 0, 0, I'm going to go right 3 and up 5, and that will be my starting point. 1, 2, 3. So right 3, up 5. And there's my starting point. Now my graph has also been stretched by 2. So my normal would be up 1 and over my odds. But I'm stretching it by 2, so now I'm going up 2 and over my odds. And my odds are 1, 3, 5, etc. So to get my next point, I go up 2 over 1, then up 2 over 3. And then on my graph, up 2 over 5 would be somewhere up here. One more up, can't reach it. But this would be what my graph looks like. Now for 16, we're going to write the equation. So we're going to start with the f of x equals the square root of x. Left 6 means inside our square root is gone left 6 and it's opposite. So left 6 would be a plus 6 on the inside. Up and down is adding and subtracting on the outside. So down 4 means we'd subtract 4 from the outside. And reflected is kind of in the same spot of a stretch. It's going to be a negative in front.